In this video, we'll be understanding the divisibility rules instead of just memorizing them by using simple place value expansions. So for example, like if I consider a number A, B, C, D, E, so by using place value expansion, I can write it as 1000A plus 100B, 10,000A plus 1000B plus 100C plus 10D plus E. So now like I can take 2 common, so 2 as a factor out of the first 4 terms. So I can write it as 5000A plus 500B plus 50C plus 5D plus E. So that means this entire thing is a multiple of 2. So therefore this E, so that means the last digit will determine whether our number is divisible by 2 or not. So in the same way, so if we take like 5 common, or so let's say 10,000A plus 1000B plus 100C plus 10D plus E. Suppose if I take 4 common, so that means it is 2500A plus 250B plus 25C plus 10D plus C. So that means like this 10D plus C will determine like whether our number will be divisible by 4 or not. That means, so for divisibility rule of 2, so last digit must be divisible by 2. So in the same way, for divisibility rule by 4, last 2 digits must be divisible by 4. Must be divisible by 4. Now the same way, like if we take for 8, so the same thing if I take for 8, like I can take, this is 12500A plus 125B plus, this will be, so we can't take 8 from it. So this is 100C plus 10D plus C. So that means last 3 digits must be divisible by 8. So that is the divisibility rule for 8, 4 and 2. So if we see like similar to like this 2, 4 and 8, we can also take 5, 25 and 30, 125. So in the similar way, like if we have A, B, C, D, E, so I can write this, like if I expand like 10,000A plus 1000B plus 100C plus 10D plus E. So I can take 5 common and write this thing as 2000A plus 200B plus 20C plus 2D plus E. Or I can take 25 common and write this thing as 400A plus 40B plus 4C plus 10D plus E. Or if I take like 125 out, so I can write the same thing as, so this will be 8B, so this will be 80A, and this will be 100C plus 10D plus E. So divisibility rule of 5 is last digit must be divisible by 5. The divisibility rule of 25 is last 2 digits must be divisible by 25. And divisibility rule of 125 is last 3 digits must be divisible by 125, because this part, like I mean for 125, this is divisible by 125, and for 25 this is divisible by 25. So therefore, like if we try to see, like if we generalize this thing, so for 2 to the power k, the divisibility rule of 2 to the power k is last k digits must be divisible by 2 to the power k. And in the similar way, for 5 to the power k, last k digits must be divisible by 5 to the power k. Must be divisible by 5 to the power k. Now in the similar way, we can also derive the rule for 3 and 9 in the same way. So if I take like same number A, B, C, D, E as 10,000A plus 1000B plus 100C plus 10D plus E. So if we write this thing as 9999A plus 999B plus 99C plus 9D plus A plus B plus C plus D plus E. So this thing is 9 times 1111A plus 111B plus 11C plus D plus A plus B plus C plus D plus E. Or the same thing, we can also write it as 3 times 3333A plus 333B plus 33C plus 3D plus A plus B plus C plus D plus C. So that means any number if we expand, so this part is divisible by 9, and this part is divisible by 3. So therefore, for any number, the sum of the digits will determine whether our number is divisible by 3 or not. Or so basically, for both divisibility rules of 3 or 9, is that the sum of digits must be divisible by 3 or 9. Now for 7, so for the numbers like 7, 13, 17, 19, 23, 29, so we can understand the divisibility rule in a more different way, or like we'll derive the rule in a more different manner. So if we take again like A, B, C, D, E, I can write this thing as 10,000A plus 1,000B plus 100C plus 10D plus E. So what I'll do is like I'll add and subtract by 20 times E. So I'm adding 20E and subtracting 20E. So this would be 10,000A plus 1,000B plus 100C plus 10D minus 20E plus 21. So if I take 10 common, this is 1000A plus 100B plus 10C plus D minus 2E plus 21. So now like if we see like this is divisible by 7 and this is not divisible by 7. 10 is not divisible by 7. So that means this thing will determine, this part will determine whether our number like A, B, C, D, E is divisible by 7 or not. So that's how like we are framing the divisibility rule of 7. So if you're having like A, B, C, D, E as our number, so A, B, C, D minus 2E must be divisible by 7. So that's the divisibility rule of 7. So in the same way, we can also do like divisibility rules of some other numbers. For 7, like we can also derive this thing in some other way. So for example, if I consider, so instead of this thing, suppose like if I'm manipulating this thing as, suppose I'm adding and subtracting. Let's say we are adding and subtracting by some different number. Let's say we are adding and subtracting by 49E and subtracting 49. So this will become like plus 50E minus 49E. So that this will become plus 5E and this will become minus 49. So that means we can see the divisibility rule of 7. Divisibility rule of 7 is either A, B, C, D minus 2E or A, B, C, D plus 5E must be divisible by 7. Now like we can derive the same rules, a similar sort of rules by using this method for different prime numbers like which are less than 20 or 30. So if I consider this thing again, so in this setup, like suppose if I subtract, let's say, so for 13 if we are deriving, so we can just add and subtract 90E here. So this will become minus 90E plus 91E. So this becomes 99E and this becomes 91E. So if we try to say this 10 is not divisible by 13 and this 91E is divisible by 13. So this 1000A plus 100B plus 10C plus D minus 9E. So if that part is divisible by 13, then this entire number A, B, C, D, E will be divisible by 13. So for 13, like we can see like A, B, C, D minus 9E must be divisible by 13. Or on the other hand, so if we do like just like the last example, like suppose let's say if I'm adding and subtracting, let's say here 39E if I'm adding and subtracting. So let's say if I'm adding here 39E, and subtracting by 39E. So this will become minus 40E and this will become 39E. So this will become plus 4E and this will become 39E. So that means again, like if we readjust this a bit, so 10 is not divisible by 13, 39 is divisible by 13. So this ABCD plus 4E will decide whether our number is divisible by 13 or not. So therefore, like if we see, like for 7, the divisibility rule is, like for example, if we are having a number ABCDE, so for 7 the divisibility rule is ABCD minus 2E or ABCD plus 5E must be divisible by 7. And for 13 the divisibility rule is ABCD minus 9E or ABCD plus 4E must be divisible by 13. In the similar way, we can also derive for 17, 19, 23, 29. So we can also derive the same. Like for example, for 17 here would be ABCD minus 5E, here ABCD minus 17E, here ABCD minus, so we have to look for the nearest multiple, like having multiple of 23 having 1 as the last digit, so that is nothing but 23 sevens 161, so 16E. And for 29, so 29 I think like 29 nines, which is 261, so basically 26E. So that's one way to understand this divisibility rules. And for all this, like we can use the similar method by using this place value digits, place value expansions. So we can also write this thing as ABCD plus 12E or ABCD plus 2E, ABCD plus 7E, ABCD plus 3E. So generally, like we use, like for 7 we use ABCD minus 2E, for 13 we use ABCD plus 4E, for 17 we use ABCD minus 5E, and 19 we use ABCD plus 2E, and for 23 and 29 it's better to use ABCD plus 3. So like how does these things help? Like so this will help us to first understand like some, like prime factorization is a key thing in number theory. So because like prime factorization will help us in like it's a very core and basic concept of number theory. So like whether it is modular arithmetic or whether it is algebraic number theory, or whether it is finding GCD and LCM, or like if we are solving problems using Legendre's formula or number basis, like so prime factorization is the core, like, or like if you are finding the number of factors, sum of factors. So for doing prime factorization, so we can use this divisibility rules to quickly find like whether a particular number is prime or not. Like for example, like if we have a particular number n, and if we have to check whether a particular number, whether this number is a prime number or not, so what we can do is we can take square root of n, and less than the square root of n we can write all the prime numbers less than the square root of n, and then like we can just cross check whether our number is divisible by these numbers. Like for example, if we take 527, so by looking, like 527 may seem like a prime number, but like if we take its square root, 527 square root is, it's around like 22 point something, so less than that, if we consider the primes, they are nothing but 2, 3, 5, 7, 11, 13, 17, 19, and then 17, 19. So now we can see like is the last digit is 7, so it's not divisible by 2. Sum of the digits is 14, so it's not divisible by 3, it's not divisible by 5. Now for 7, 52 minus 2 times 7, that is 52 minus 14, which is 38, so that means it's not divisible by 7 as well. And for 11, I didn't discuss the divisibility rule yet, I will discuss that. But we can see 12 minus 2, 10, it's not divisible by 11 as well. Now for 13, like we can use 52 plus 7 times 4, 52 plus 28, which is 80, so it is not divisible by 13 as well. And for 17, 52 minus 7 into 5, which is 52 minus 35, which is 17. So that means it is divisible by 17. So this is nothing but 17 times 17 threes and 17 ones. So 527 is not a prime number, it's a composite number. So by using this divisibility tricks and by using the identifying like whether a particular number is prime or not. So we take the square root and we find all the primes less than that particular number, and we'll just cross check whether a particular given number is divisible by those primes or not. So, and if we come to the divisibility rule of 11, so we know like a cube plus b cube, or so whenever we or like if you are having a to the power k plus b to the power k, so a to the power k plus b to the power k, so is it divisible by a plus b? And is a to the power k minus b to the power k divisible by a minus b? So the answer for the first one is not every time, because a to the power k plus b to the power k is divisible by a plus b only if this k is odd, whereas like this a to the power k minus b to the power k is always divisible by a minus b provided k is any natural number. So here also odd natural number, and a to the power k minus b to the power k is divisible by a minus b when k is natural. So if we consider like 10 to the power odd plus 1 to the power odd, so this is divisible by 11. Whereas if we are having 10 to the power even minus 1, so that is also divisible by 11. So if we consider a, b, c, d, e, so we are writing it as 10 to the power 5 into b plus 10 to the power 5 into a plus 10 to the power 4 into b plus 10 cube into c plus, it should be 10 to the power 4 into a plus 10 cube into b plus 10 square into c plus 10 into d plus e. So if I add and subtract, so basically here if I am subtracting, and for 10 cube I am adding, so I need to subtract b, and for 10 square into c I am subtracting c, so plus c, and for this is 10 plus 1 into d minus d plus e. So if we try to see 10 to the power 4 minus 1 into a plus 10 cube plus 1 into b plus 10 square minus 1 into c plus 10 plus 1 into d. So this part is divisible by 11. And if we consider this part a minus b plus c minus d plus e, so this is not divisible by 11. So basically we can say like if we are having a, b, c, d, e, so we can write it in this form, like from the place value expansion we can write it in this form. So we can see this part is divisible by 11. So this will determine whether our number a, b, c, d, e is divisible by 11 or not. So that means this is nothing but sum of difference of sum of alternate digits. So that means we are finding sum of digits at even positions and sum of digits at odd positions, and we are trying to take that difference and we are trying to check whether this particular difference is divisible by 11 or not. So that's the divisibility rule of 11. So that's what here as well, like I did. So 527 is 5 plus 7 minus 2, which is 12 minus 2, which is 10. So 10 is not divisible by 11. So 527 is also not divisible by 11. So that's the divisibility rule of 11, and the primes like 2, 3, 5, 7, 11, 13, 17, 19 and 23. Now like if we consider the divisibility rules for composite numbers. So any composite number we can prime factorize as some p1 to the power alpha 1, p2 to the power alpha 2 and so on pn to the power alpha n. So any composite number we can prime factorize it into product of primes. So now like the divisibility rule, so for composite numbers, so the divisibility rule would be, so the divisibility rule of n is the number n, we just have to check like it must be divisible by p1 to the power alpha 1, p2 to the power alpha 2, like each individual thing it must be divisible. Like for example, if we are having 12, so it must be divisible by both 4 and 3. That's the divisibility rule for 12. And for 18, it must be divisible by 2 and 9. So 18 can be also written as 3 into 6, but 3 into 6 is not a, I mean, it's not a divisibility rule for 18. So for 6, the divisibility rule would be, it must be divisible by 2 and 3. And for example, like if we are having 36, the divisibility rule would be the number must be divisible by 4 and 9. And so like if we are having, let's say, 280. So if we are having 280, the prime factorization of 280 is 4 into 70, or 8 into, so 2 cube into 5 to the power 1 into 7 to the power 1. So that means this number must be divisible by, so any number, if it is divisible by 8, 5 and 7, or we can say 40 and 7, or we can say 8 and 35, or we can say 5 and 56. So we just have to ensure that the individual rules, the individual checks that we're doing, they all must be co-prime. So here if we take the GCD of 8, 5 and 7, that is 1. And here GCD of 10, 40 and 7 is 1. And GCD of 8 and 35 is also 1. And GCD of 5 and 56 is also 1. So that's how like we devise the divisibility rules for composite numbers. But the more important thing is of prime numbers. So I hope like you understood like how we are deriving these divisibility rules for prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19. So this is the way like in which like we can derive the divisibility rules for these all sort of prime numbers. Like, so we just have to look for a digit which is ending with 1 and it's a multiple of our concerned number, or and we can check by using this process, like simple place value expansion. So that's it for this video. We'll meet in the next video.